Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. So we are into unit number 4 where we are discussing about push-down automata, and this is lecture number 4 where we are learning about push-down automata and context-free grammars. Okay, so basically in this particular this particular lecture, we are dealing with the equivalence of push-down automata and context-free grammar. Actually, equivalence of push-down automata and context-free grammar means that if you are able to get a push-down automata for a particular context-free grammar, or if you are able to get context-free grammar from a push-down automata, then we can say that both the two things, that means push-down automata and a context-free grammar, are equivalent. Okay, so in this part we are looking into the second topic, that is how to construct or how to get a context-free push-down automata from a context-free grammar. Okay, the example is given to you, but if you use your own logic, yes, from this particular example, I can derive a particular string, and for that particular string I can draw a push-down automata by using the transition diagram or else transition function. But if you use your logic, then that is only for one particular string or 2 or 3 or 4, right? You cannot get a universal string for that. Or else if you can derive a language from that, if there is a certain similarities for the strings, suppose you have derived A, B, B for string. Second, you have derived triple A, triple B. Okay. Then third, you have derived A to the power A 4 times, then B 4 times. Then you can understand that the language is A to the power n, B to the power n. Correct? So for that language, you can directly draw a push-down automata. It's not a big deal. Correct? But if there is a grammar, where you are getting all the strings of different types, you cannot directly assume that particular language from that grammar. For that, what you can do? So there are certain you can say algo, or you can say a set of rules for constructing this or for conversion of this. Okay, so I've defined already the 2 rules over here, and based on these 2 rules I will draw, or I will construct a push-down automata, and I will also test a particular string from that. Clear? So let us check it out first, the rules. So rule number 1 says that suppose I am deriving this particular definition part, that L is a language of a grammar G, where grammar is defined by Vn, Vt, S and P. Vn means set of non-terminals, that means capital letters, correct? Then Vt means set of terminal symbols apart from whatever capital letters are present in the grammar are terminal symbols. Then S is the start symbol and P is the set of productions. So here P is the set of productions are these, correct? Okay, now leave this particular grammar example part. So to construct a PDA, the rules are rule number one, if, first check this part, if A belongs to A derives alpha is in P, that means this if we get a particular production in this form, that means A is nothing but a non-terminal symbol, right? If there is a single non-terminal symbol that derives an alpha is in P means production, that means alpha can be a non-terminal, can be a terminal, or can be a combination of both, or can be epsilon, correct? Clear? So if you get a production like this form, then you have to write down the transition function in this format. That means delta Q may be the state. So I will, in this particular example, I will take only one state only. I won't be taking Q1, Q2, Q3. I will take only one state, Q epsilon. Okay, epsilon means that is nothing, empty. Then A is the non-terminal symbol, is equals to Q means the same state, and alpha means whatever in the right hand side of the production rule. Clear? So this is one rule. Now second rule says that if for every A belongs to terminal symbol, that means for every terminal symbol, single A, or you can say A, B, C, anything, any terminal symbol, then you have to write down the transition function in this format, delta Q, then the terminal symbol, followed by the terminal symbol, and then Q, then epsilon. Okay. Clear? Again, I'm repeating these particular portions you always remember. Okay, this is your current state, this is the element to be read, this is the top of the stack, and this is the current or next state, and this is the element where push or pop operation is done. Clear? This is the part. So these particular positions you should remember. Okay, and here on singing a current state, suppose Q, if you are reading the input element as A, that is a terminal symbol. If the top of the stack is A, what I have to do? I have to do only the pop operation. Clear? So these two rules you have to memorize. Now based on these two rules, it will be a little bit, maybe it might be a difficult for you to understand. Let us take the example and understand this particular topic. Okay, now the grammar is given to you. Clear? The grammar is given to you. So let us start off with the first transition function. So PDA say A. So therefore transition function delta will be number 1 for the first one. Okay, now first one is always starts off with capital letter S. Okay, so S tends to BS will be the first one. S tends to BS will be the first production that I'm taking. That means this production is of the form rule number 1. A tends to alpha. A means this non-terminal S, and alpha is a combination of two non-terminals. Correct? That means this particular production falls into rule number 1 category. Clear? So what I can do according to rule number 1, what will be the step? You have to remember this, the transition function, correct? Then Q I have taken, this is a universal state that I am taking. Okay, so nothing to be read. What is the top of the stack? S. What is equals to again Q, and what is the alpha side? Alpha means right hand side of the production, BS. Clear? Again for S, one more production is there for A. So again I will write the same thing, delta Q, correct? Clear? Then nothing to be read. S I am reading right now, top of the stack, Q, and for S right hand side is what? A. So first S is done. Now similarly I have to do with A also. A is having a production which is of the form what? A tends to alpha, correct? Again I have to write for this. Again here A tends to alpha. Alpha again I have told you that alpha can be a single terminal, single non-terminal, combination of terminal and non-terminal, or epsilon, right? So it can be of this format also. So this is all of A tends to alpha format. So number 3 will be what? Number 3 will be delta. Clear? Q, nothing to be read. Now A I am doing. So Q, for A, what are the right hand side? That is alpha, 0A. So 0A I have to write over here. Then number 4, clear? Again I will write the same thing, Q epsilon for A. Then this will be Q epsilon. Clear? Now what is left out? I am left out with B. B is having a format, B tends to BBA. What is this format? A tends to alpha format, right? So what will be the production format? The same one. What I have to write? Number 5, delta Q epsilon. What is the non-terminal? B. So what will be the part? BB1. Clear? Then again I have to write down the same thing for the another transition, that is B implies number 2. This is also of the form A tends to alpha, correct? So what I have to write? 6 delta Q epsilon B. Then for B I have to write down as Q number 2. So here I have wrote down all A tends to alpha format. Clear? Now am I left out with anything? Yes. I have done the A tends to alpha format. Now I have to write down the transition function for all non-terminal symbols. Now what are the terminal symbols over here? 1 is the terminal symbol, correct? 2 is the terminal symbol. 0 is the terminal symbol, and epsilon is also a terminal symbol, right? So I have to write 4 transition functions for these 4 terminal symbols, right? So number 7 will be Now look at this rule number 2. Rule number 2 says that for every A belongs to terminal symbols. That means for every A, for every terminal symbol, that means here are 4 terminal symbol, 0, 1, 2 and epsilon, right? For all I have to write down this format of transition function. So what will be number 7? Delta Q, correct? Then what is the format? A here is first is epsilon, then again epsilon, then what will be the format? Epsilon. This means popping operation, right? Now number 8, delta, then Q, what will be the next one? 0, 0, Q, epsilon, correct? Number 9, delta, Q, 1, 1, then Q, epsilon. Why? I'm just following this rule. That's it. The number 10, delta, Q, then 2, 2, Q, epsilon. So I have completed all the transition functions, transition steps based on these 2 rules. Clear? Till here, okay, till here I have drawn for A tends to alpha format, and till here I have drawn for all terminal symbols. Clear? So this is the final PDA that I have drawn. Now can I test a particular string, and I will let you know that whether it is okay or not. Okay. So for this particular grammar I am writing down over here. Okay. For this particular grammar, let us derive a particular string. Okay. S tends to BS. Correct? S tends to BS. Now first one I have taken. Okay. Now for B I am taking as suppose for B I am deriving as BB1. BB1S. Clear? Then for first B I am deriving this particular 2. Okay. Then 2B1S. For this B again I am writing this 2. 2 to 1S. Okay. For S I am taking this A, suppose. Okay. So 2 to 1A. For A I am taking that 0A. Okay. Then what will be the string? 2 to 1 0 A. And this for A I am taking as epsilon. So what will be the string? 2 to 1 0. So for S I am taking this string as whatever I have derived. Based on this I will test these particular steps. Okay. Clear? So this is the PDA, this is the final answer for you, but there might be a question like this, that you have to test a particular string and for the final PDA that you have constructed. Clear? Okay. So I have already derived this particular string 2210, and for this I will check that this PDA is working successfully or not. Okay. So let us move into this particular topic. Okay. Now the string is 2210. Clear? So first step that I am going to take is, initial state is Q. What is the string that I am reading? 2210. And what is the first top of the stack that I am going to deal with? Is S. Clear? Because S is the only symbol with which you are starting off with the productions. Correct? So S is the starting production. S is the starting non-terminal, right? So with S you have to start off with the process. Clear? So I have taken S. Now number 2. Okay. Now from S, now you have to check it over here. Now which rule you are going to follow first? That means in place of S, what we are going to substitute in order to reach to the first terminal symbol 2. Correct? So I can go with rule number 1 as, because for S what is being derived? BS. Correct? So I can write down Q 2210 and then BS. This is by rule number 1. Clear? Number 3. Okay. Now Q. So I have derived this particular step by using rule number 1. Clear? Now 2210. Again the string is going on, because when you can pop a particular first 2, when you will get a 2 over here. Okay. So for B, now I will check out for only B. So for B what I can take? I can take rule number 5, that is BB1, correct? So I can take here BB1. Already S is there, so I have to keep S. Clear? So this will be rule number 5. Any doubt? Okay, now number 4. Okay, now Q2210. Now, if you check over for first B, you have to substitute from left hand side to the right until you reach the right hand side. Clear? So left hand side B. So what I can, because I am dealing with the first one, right? So definitely I have to deal with the first left hand side. Clear? Now if I remove this B, okay, which rule you are going to follow? I can follow this particular one, 6, rule number 6, correct, where B, I am substituting what? 2, correct? So I can write it down as 2B1S. Clear? So what is this rule number? Rule number is 6. So now you can check that these two are common. That means the input string that you are reading on top of the stack is matching. Then what you can do? You can do the pop operation. Clear? So this will be automatically pop. So once I have popped, now what I am left out with, Q2 is gone, then 210 is left out, and what is in this side? B1S. Clear? Any doubt? Now this is for this particular process you can write it down. Which rule number? Because on sync input symbol 2 and top of the stack 2, you are doing pop operation. So which is the rule you are following? Rule number 10. See, on sync input symbol 2 and top of the stack 2, you are doing what? Pop operation. So what is this? Rule number 10. So you can write it down here, rule number 10. Clear? Now next step, number 6. So in 6, Q210. Now in place of B, what you can write it down? You can pause the video and you can think of it. Earlier what we did for B, I have replaced by 2. By which rule number? Rule number 6. So again I can use rule number 6 and I can write down as 21S. Clear? Now these two are common. That means input symbol that you are reading 2 and the top of the stack is same. So which rule you have to follow again? Rule number 10. Very good. That means number 7 transition will be Q. This will be pop by using rule number 10. Clear? So this 2 will be gone. Then 10 will be remaining and 1S will be remaining. Again you can check this 1 common, right? That means this terminal symbol 1, input symbol 1 on reading this and top of the stack is 1. Then what we have to do? We have to do the pop operation. So which is rule number? Which is this rule number? Rule number 9. So rule number 9 says that on reading input symbol 1 and the top of the stack 1, then you have to do the pop operation. So whatever the same thing over here. So number 8 step. Sorry, this will be Q. Then 1 will be over, then 0 and S will be remaining. Now, my dear, what is left out? Only S is left out. So S, if you can check it out, which rule you are going to follow? Because you have to go with A, right? So S, because 0 is present, I have to finally merge with 0, right? I have to finally compare with 0. So how can we get 0 through S? Through A, I can get 0, correct? So first of all, I have to apply this rule. Rule number is what? Rule number is 2, correct? So if I replace this by rule number 2, so what will be the direction? Rule number 2, and this will be number 9. So this will be Q, 0, A. Now left out with this A. So can you just let me know what is this A? How can you replace? Rule number 3 I can replace through A, 0A, correct? So I can replace this one by rule number 3. So this will be Q, 0, 0A. Now I am left out with 0, 0. So this will be automatically pop, correct? So how can you use this particular? On seeing input symbol 0 and top of the stack 0, you have to pop. Which rule? Rule number 8. So by using rule number 8, I can write it down here. Rule number 8, I can write it down here as Q, epsilon. Then this will be A. Clear? I'm writing over here. Okay. writing over here. So rule number 8 is done. By using rule number 8, I have popped this 0. Correct? Only I am left out with epsilon. So what I have to remove? I have to remove a. So if I remove a, which operation you are going to take? I can take this rule number 4, where on the top of the stack a, and I'm doing getting the epsilon symbol. Correct? So I can write it down, number 12, q comma epsilon comma epsilon. Correct? And this I have used by rule number 4. So once I reach this kind of scenario where the state is q, input symbol is epsilon, and also the element that I have reached is epsilon, this means what? Your entire scan, your entire string has been read from left to right. Clear? As you can check it down, that these 2 has been removed here, then again these 2 has been popped over here, then 1 is left out, 1 is also popped over here, then 0 I have popped over here, and then finally I am left out with epsilon. That means you have reached into the final state. You have reached into the final state, and which means that you have read this particular string properly with the help of these transition function rules that I have constructed for the required PDA. Clear? So this is actually an additional step that I am showing over here to verify that this PDA that I have drawn is correct or not. Okay, you can also skip this part, but yes, sometimes there might be a question regarding this. Okay, so thank you for watching this video. You can I will by the end of this video lecture series, I will also give you 3 to 4 questions where you will get these kind of examples. Okay, and then you can attempt those. Okay, so in the next lecture, I will let you know the concept of 2-stack pushdown automata. Okay, thank you for watching.